Friends, today in this video we are going to learn the category of boundary value analysis method. Basically there are four classifications of boundary value analysis methods are there to test a given program. First one is generalized boundary value analysis method. Second one is robustness boundary value analysis method. Third one is worst case boundary value analysis method. And the last one is the combination of these two, that is robustness boundary value analysis method and worst case boundary value analysis method. This is what last one, robust worst case boundary value analysis method. In this video we will going to learn all these classifications of the BVA or boundary value analysis method. First, under the generalized boundary value analysis method, so basically this boundary value analysis method is one of the black box testing technique. In this testing technique, all the inputs which we are specifying for a given program, all are valid input variables. All the inputs are boundary value variables. So like example, minimum, minimum plus, nominal, max minus and max. These are the 5 input variables we are specifying for a given program. These input variables are valid input variables, and also we are calling it as these variables are boundary value variables. By using these boundary value variables, we are going to test the given program. These inputs are given to the program based on the single fault assumption. Means how we need to specify these inputs. So if 2 inputs are there, then the combination of the inputs are different. If 3 inputs are there for a given program, then the combination of inputs will be given in a different manner. So based on this single fault assumption manner, we need to specify input for a given program. What is the meaning of single fault assumption? The single fault assumption is nothing but, for example, if a given program accepts n input variables, in that out of n input variables, one input variable for one time we need to keep on changing with respect to the boundary value variables, and remaining input, it should be always a nominal variable value. Understood? I will repeat. The single fault assumptions means if a program is accepting n input variables, out of these n input variables, one input variables we have to keep on changing with respect to the boundary value variable, like minimum, minimum plus, nominal, max minus, max, in this order. And the next and remaining other inputs we have to write it as a nominal. This is what one time one input variable we will keep on changing with respect to the boundary value variable. That is the meaning of single fault assumption. I think it's clear. So then how many number of test cases will be existed in the boundary value analysis method or generalized boundary value analysis method? To identify number of test cases should be present in the generalized boundary value analysis method, we are using a formula. That formula is 4n plus 1. This is the generalized formula. So where n indicates that number of inputs, how many number of inputs you are specifying for that program. So 4 into that many number of values plus 1, that will be the final, that many number of test cases we are generating under the generalized BVA. For example, I will tell you, if a triangle program is there, the triangle program will accept the 3 inputs. Let us assume that A, B, C. These 3 A, B, C value will act as a sides of a triangle. Then the number of inputs, how many inputs we are specifying for a triangle problem? 3. Then n value will becomes 3. Then how many test cases will be existed under the generalized BVA? So 4 into 3 plus 1 means total 13 test cases we have to write under the, so for a triangle problem by using this formula. Okay. So this is the diagram how generalized boundary value variables will be existed. So let us consider here program f is one function which f acts as a program. Here x1 and x2 are the 2 inputs for this program implemented as a f. Here a to b is the upper limit and lower limit of the x1 variable, and c to d is the upper limit and lower limit of the x2. Here you can see here I have pointed 1, 2, 3, 4. These 4 are the points where we are selected the 4 input variable on the borders, like upper limit or lower limit. This is the middle center one in dot is there. It indicates that nominal value. Okay, I will repeat, this indicates that nominal value. If I am considering this line is the lower limit, then this line will becomes upper limit for designers. If I am considering this one as a lower limit, then this line will becomes upper limit. Based on that, I will be explaining these points. Now, so if I am considering this line is the lower limit, then this will becomes minimum value. Now this second point is that this will be the minimum plus. Third point is that becomes nominal. Then next point is that this will becomes max minus, and this will becomes maximum. Means minimum, minimum plus, nominal, max minus, max. This is how we are identifying the boundary value variables on the generalized BVA method. If we are considering this line as a lower limit, then this will becomes upper limit. Then we need to consider in this fashion. This will becomes minimum, minimum plus, nominal, max minus, max. I think so. This is about your generalized boundary value analysis method. In the next video, we will start with an example of all the 4 methods. We will apply all the 4 methods. Next, second one, we will move to the robustness boundary value analysis method. Robustness. Now we will start with the robust boundary value analysis method. So robust indicates that invalid inputs. Please remember, robustness is nothing but invalid input variables. So robustness boundary value analysis method is also one of the black box testing technique, or we can also call it as functional testing technique. So here we are giving inputs, both valid inputs and as well as invalid inputs. So already valid inputs are nothing but all of us know that. So these are the valid input variables or boundary value variables. Valid input boundary value variables: minimum, minimum plus, nominal, max minus, max. When we compare to a generalized boundary value analysis method, the same variables we are using along with the valid input variable, that is boundary value variables, we are using 2 invalid input variables, that is minimum minus and maximum plus. These are the 2 variables are there. These variables we are calling it as a invalid input variable or invalid input boundary value variables. Okay. These are the valid input variables. Please remember, these 2 will becomes invalid inputs. These 5 variables are there, that will becomes a valid input variable for a program. So here when I compare to these 2, generalized and as well as robustness, so extra these 2 variables we are including to the robustness, but here we are not including that one. Here only we are checking for a valid input variable only, means we are testing the program for only for valid input variable. But here along with the valid input variable, we are testing an invalid input variable also, means above the boundary inputs and as well as below the boundary. So we are going to check how. So how the test cases we will going to provide or specify for a given program. So here also I told in the generalized boundary value analysis method, so based on the single fault assumptions, the inputs combinations will be given to the program. Here also we will be specifying a single fault assumptions. We will also use a single fault assumption technique to specify the different set of input parameter list for a given program. So once again I'll repeat what is meant by single fault assumption. If n inputs are there for a given program, out of that n inputs, one input variable value we need to keep on changing with respect to the valid input boundary value variables, like minimum, minimum plus, nominal, max minus, max. And so next remaining inputs at the remaining input we need to keep it for a nominal. That is the meaning of single fault assumption. Means one input variable we have to keep on changing and other input should be a nominal inputs. Next, so how to identify the number of test cases, how many number of test cases needs to be existed under the robustness boundary value analysis method. This is the generalized formula. Based on this formula, we can identify the number of test cases should be existed in a given program to test a given program. That is 6n plus 1. where n indicates that number of inputs of a program. So for example, similarly, I explained over here in the generalized BVA. So n is nothing but number of inputs. For a triangle problem, we are specifying the 3 inputs. 3 inputs are acts as a 3 sides of a triangle. In that case, the n value will be a 3. Then 6 into 3 plus 1. Total 19 test cases we are generating for your triangle problem. Okay. Next, so we will, you can see here, this is the diagram how we need to specify the robustness boundary value analysis method for a 2 input variables. 2. So here x1 and x2 are the 2 inputs of a function implemented as a program f. Here, so this is the lower limit, this is the upper limit, and this is the lower limit, this is the upper limit. Here, so this diagram is same as a generalized boundary value analysis method diagram. The major changes here, I need to include 2 more invalid input variable for this diagram. So now you can see this is the minimum. So I need to make it as a minimum minus. Next, to identify the minimum minus, you can see here, I will put one extra dot. This indicates that minimum minus. Now, if I put one more dot over here, this will becomes maximum plus. Now, if I am considering this is the lower limit and this is the upper limit. Similarly, I am considering for this is the lower limit, this is the upper limit. Then this point will becomes minimum minus and this point will becomes maximum plus. You can see here, these points are there. These points are outside the range. This is the input domain range. So these points are there. You can see here, these are all minimum minus and maximum plus values. These values are outside the range, so which are all not included within the given range. Therefore, so these input variables we are calling it as an invalid input variable. This is about your robustness boundary value technique. Now we will discuss the third category, that is worst case boundary value analysis method. So when we compare to these two category to this worst case BVA, why we are calling it as a worst case test cases means, here we are doing the redundancy of the output results will be more number of redundancy output results will be existed as compared to the robustness boundary value and as well as generalized boundary value analysis method. In the generalized boundary value analysis method and the robustness boundary value analysis method, we will be getting the redundancy of the output results will be very less as compared to the worst case boundary value analysis method. Okay, now we will start with so that's what we are calling it as a worst case. Worst case means, so we are getting a same set of output results a more number of times, n number of times. That's what we are calling it as a worst case. So BVA. The worst case BVA is also called it as one of the black box testing technique. Here all the variables or input variables we are specifying all are valid input variables for a given program. So to do the testing we are giving a valid input variables only. The valid inputs variables are nothing but boundary value variables. The boundary value variables, all the valid input variables are, these are all. One is minimum, minimum plus, nominal, max minus, max. These are the 5 variables which we are using for a worst case BVA. But when compared to generalized BVA and robustness BVA, so these two are single fault assumptions. I initially told that these two are the single fault assumptions, but here it is multiple fault assumptions. The meaning, what is the difference between single fault assumption and multiple fault assumption means? Single fault assumption, I told that if a program accepts n inputs, out of n inputs, one input variable we have to keep on changing with respect to the boundary value variables, and other inputs we need to keep it as a nominal. But here there is no any such type of single fault assumption. It is a multiple fault assumption. So 2 or more number of input we are going to change with respect to the boundary values, and other inputs are also going to change with respect to the. So here there is no any such type of restriction. So we need to maintain all the input variable values will be keep on changing with respect to the different set of input parameter list. Now, how many number of test cases we are generating under the worst case BVA for a given program? So for a given program, so we are using one generalized formula, that is 5 to the power of n, where n is nothing but number of inputs of a given program. Based on that number of inputs, we are going to generate that many number of test cases under the worst case boundary value analysis method. For example, I will tell you. So for a triangle problem, 3 inputs we are specifying for a triangle problem. So that is n value will becomes 3. So when n is becomes 3, 5 to the power of 3. 5 to the power of 3 means we are generating the total 125 test cases for under the worst case BVA. So now you can think we are generating 125 test cases, then obviously or automatically there will be a redundancy of the output results. So when same set of output results we are occurring more n number of times, then we will call it as a worst case boundary value analysis method. That is one of the drawback of this worst case boundary value analysis method. Now you can see this figure. I will explain. So for a 2 input variables, so we have drawn the worst case boundary value analysis method diagram. Here x1 is the one input variable and x2 is another input variable for a function f. F is implemented as a program, then x1 and x2 will become a 2 input variable for that program. Here this is the diagram which we have already went through with the generalized boundary value analysis method. You can see here this is the lower limit, this is the upper limit, this is the lower limit, this is the upper limit. Here this points will becomes minimum, this point will becomes maximum. The minimum plus nominal, max minus and max. You can see similarly minimum, minimum plus nominal, max minus and max. So now, under the worst case we are using only valid input variable, but redundancy will be more. So therefore the diagram will be looks like this. Means so we are getting the same set of output result in a redundancy way. Therefore you can draw the diagram in this fashion. That are all either maximum or maximum plus, minimum, minimum plus or nominal. Okay, these are all the values. You can call it as minimum, minimum plus, minimum, minimum plus, minimum, minimum plus, max minus, max minus, max minus. Means more number of max minus value we are going to give it as an input parameter list. Two or more number of times we are specifying the boundary values, that are all maximum, minimum, minimum plus and also nominal also. Therefore this type of testing technique we are calling it as a worst case test techniques. Now this is the fourth method, that is robustness worst case boundary value analysis method. This is the fourth method, is nothing but it is a combination of second method and third method. Second method is nothing but, so you can see here robustness boundary value analysis method and worst case boundary value analysis method. This is the combination of robustness worst case boundary value analysis method. So this is also a black box testing. So here we are using both valid inputs and invalid inputs to test the given program under the robustness worst case boundary value analysis method. Valid and invalid inputs are nothing but the combination of both boundary value variables, that is valid inputs and as well as invalid boundary values. One is, you can see here, minimum minus, minimum, minimum plus, nominal, max minus, maximum and maximum plus. Here the maximum plus and minimum minus are the invalid input variables and remaining 5 variables are there, that are all valid input variables. So these input variables we are using as an input for to test your given program. So this is works, all the input variables we have to specify based on the combination. That combination we will call it as a multiple fault assumption. Means based on this multiple fault assumption manner, we are specifying the inputs for your given program to test the program. What is the meaning of multiple fault assumption? I'll repeat. Here there are two assumptions are there. One is single fault assumption and second one is multiple fault assumption. Multiple fault assumption is nothing but more than one input variable value we are keep on changing, or more than two also we are going to change the input variable values. But here there is no any hard and fast rule to maintain all the input variables. But the thing is, just we have to keep on changing all the input variable values with respect to the occurrences. That is the meaning of multiple fault assumptions. The number of test cases we are going to generate under the robustness worst case boundary value analysis method is, so this formula will indicate the number of test cases generates under the robustness worst case boundary value analysis method, that is 7 to the power of n. So initially I told worst case, under the worst case, that is a 5 to the power of n, where we are using only valid input variables. But here two more inputs we are added, that is invalid inputs, that is maximum plus and minimum minus. Therefore it is not a 5, now it becomes 7. 7 to the power of n, where n indicates number of inputs of a given program. So for example, I will tell you once again, if a triangle problem is there, the triangle problem will have a 3 inputs, then 7 to the power of 3, then 7 to the power of 3 means that many number of test cases we are generating for this robust worst case boundary value analysis method. Now this is the figure. So now which I have drawn over here, this figure is an example figure of the worst case boundary value analysis method. You can see all the dots are there within a range or input domain range. But here I need to specify invalid input variable for this also. When I want to specify, you can see here. So this is the minimum. Then I need to make it as a minimum minus. This is the minimum. This will becomes minimum minus. This is also minimum minus. Maximum plus, maximum plus, maximum plus. This is the minimum minus, minimum minus, minimum minus. This is the maximum plus, maximum plus, maximum plus. These inputs are there. These dots are there. That are all indicates that inputs for a given program. These are all the inputs are invalid input for a program. That is invalid input variable that is outside the boundary which we have selected as an input for your program. Therefore, those we are calling it as a invalid input variable. This is the diagram which depicts robustness worst case boundary value analysis method.